standard stats and probability number 6, looking at using linear models to describe bivariate data. We're looking at learning target 2, which happens to be the last learning target in this standard. I can determine and use relative frequencies for rows and columns, and or columns of two-way tables to describe possible associations. So first of all, what is this relative frequency we speak of? So we'll define it here for you. While the frequency, like we talked about in the last learning target, while frequency is the number of times that something occurs, relative frequency tells us the number of times something occurs compared to the total. So frequency is like if I surveyed the number of males in here, the frequency is how many males are in here. But if I do frequency or relative frequency, that is the number of times it occurs compares to the total. So how do you mathematically find that? So to find relative frequency, you set up a ratio. On the top, you put the frequency, how often it happens over the total, then you convert it to a ratio and then to a percentage. So relative frequency is seen as a percentage or percent. We're going to round always to the nearest whole number, or I should say whole percent. So read the questions carefully to determine whether the total is referring, and this is where you get in trouble because you got to be careful, is referring to the entire table or to a certain row or column. So let's get started here. So to complete the two-way table with relative frequency, show the fractional amount you were dividing by and the decimal amount to the nearest thousandth. And then, of course, we're going to take it to a percentage. So we're going to go, and you can do this two ways, but since it has the 1 down in the column total, we're going to do this with columns. Okay, so we're going to go, we're going to add up these totals first so we know how much is coming out of. So if 28 and 97, if you add those together, it'd be 125. So 125 sport utility vehicles, known as SUVs, or sports car, 35 and 104 would be 135. So that is the totals. Now, if you want to just check, not that you have to on this one, but you could add across with accidents within the last year. So 28 plus 35 is 63. We won't be using these totals, but this might help here. And no accidents within the year. 97 plus 104 is 201. Now, if you add these, they should add up both row and column the same. So 63 plus 101 is 264, and 125 plus 135 9 is 164. So I know that my totals have to be right because it did work correctly in the two-way table. So relative frequency, frequency over total. So since we're looking at column total of 1 here, and we'll kind of explain that when we get done. So we have 28. So we're going to put 28 here over the total of 125 SUVs. So 28 SUVs that had accidents within a year out of the 135. So you're going to take 28 divided by 125, which is 0.224. And then we're going to change that to a percent. So multiply that times 100 and move the decimal over twice, and to the nearest would be 22% because it'd be 0.4, and since it's less than 5, you round it down or to the 22. Okay, so let's go no accidents within a year of the SUVs, which would be 97 over the total of 125 SUVs out there. So 97 divided by 125 equals 0.776. And if I change it to a decimal, I'm going to take that times 100 in my calculator, or multiply times, or move the decimal over twice. So that'd be 77.6. That would round up, since it's higher than 5, to 78%. Now, if you kind of look at this, if you take 0.224 and you add that to 0.776, you will notice that adds up to 1. Or if you add up the percentage, 22, plus 78 is, so that'd be 0, carry the 1, would be 100. Which is awesome, because of course you want your percents to be equal to 100%. That proves that you have mathematically used the whole entire total. Looking over here with our sports cars, I'll change color. So of our sports cars that have had accidents within the year, 35 of the 135 people that have it have had an accident within a year. So 35 divided by 139 equals, and we're going to put approximately, because this is not a pretty decimal, and we'd have to round that to a 2. Let me check my math one more time, make sure I did it correct. Yes, and then we're going to change that to a percentage. So since that 2 in the thousandths place is not higher than 5, this would be 25%. Now if we did this right, now that you notice, this should be 100. Okay, so no accidents within a year. That's 104 people that own sports car out of the 139 that own sports car. So that's approximately, and it says to the nearest thousandths, so 748. And then you're going to round that. So you're going to move the decimal over twice, 1, 2. So that'd be 75, because that 8 rounds it up, which is a good sign, because 25 plus 75% is 100%. Okay, so a couple things to notice. If you would go the other way, so I could do 28 out of 63 and 35 out of 63, and that too should add up to 100% if you do it right. So if you want to double check your relative frequency, now what you can notice when you get this done is kind of describe some associations. So I notice that the overall people that were that took this survey, most people haven't had an accident within a year, which is a good sign. I noticed there really isn't any difference between a SUV and a sports car. People have had accidents. So it's kind of interesting data to look at when you get done. I think the percentages help people make those associations and make those connections between the two bivariate data that you're looking at. Why do the columns equal 1? Well, I kind of explained that. One thing makes more sense to me if I change that to 100%. Okay, so if the columns didn't add up to 1 or add up to 100%, then you know that your relative data or frequency has to be off somewhere, because it should be 100% of the people who took the survey. So the total added up should be 1.00 or 100%. Now, the 1 can be a little bit off depending on, like this side, if you round, but if you look at that, it actually does round up perfectly, but it can sometimes be just a little bit off because of rounding. This one I didn't have to round, and notice how perfect that is. Let's look at the next problem. It says, Liz wanted to see if there's any association between people who have kids and people who have pets. So the two-way table shows her survey. So we got to complete the table first, and then we can find some relative frequencies. So kids, I know there's 63 total. If there's already 22, that means if I take 63 minus 22, that's 41. So 41 kids have pets. Let's go this way. 63 total out of 125. Remember, these have to add up. So if I subtract 125 minus 63, I'm going to get 62. Now I can go this way. So no kids and have pets is 23. A total of 62. So 62 minus 23 is 39. And then I should just be able to add this. It should work. So 41 plus 23 is 64. 22 plus 39 is 61. If I add it this way, it should work. Yes, it's 125. So I know my table is correct because the total in the corner, both column-wise and row-wise, added up correctly. So of the people who surveyed, what is the relative frequency of people who have pets? So remember, frequency on top and then total on the bottom. So frequency of people who have pets. So pets is a column here. So frequency is 64 people. The total, and you're going to have to go the big total this time because you're doing all of pets. So out of 125 people that were surveyed, so you're going to divide, and let me check my math here, 64 divided by 125 is 0.512, so 512 thousandths. And then I would take that to a decimal or to a percent and round. So if I move the decimal over 1, 2, I get 51.2. I can write that if you want me to. Percent, but then I want just the whole number percent. So since the 2 is not greater than 5, it'd be 51%. So 51%, so almost half of the people surveyed have pets. It didn't matter if they had kids or not. They just have pets. So of the people who have kids, so we're going to look at the total here. So that always helps me know what I'm going to divide by. What is the relative frequency of people who have pets? So the people who have pets is 41. Of the people who have kids is 63. So 41 divided by 63, and we're going to have to round here. So it'd be 0.65, and that actually turns to a 1. So if I look at that, move the decimal over twice, would be 65.1. That 1 as the 10th here doesn't matter, so it'd be 65%. Okay, of the people who do not have kids. So people who do not have kids. So my total this time on the bottom is going to be 62 because they do not have kids. I'll fix that here. There you go. And have pets. So have pets is 23 of the 62. So 23 divided by 62. Decimal is 0.37, and it's 0.9, so that was going to round it up to a 1. So 371 thousandths. Move the decimal over twice would be 37.1%, and then I want it as a whole number percent. Since the 1 is less than 5, it doesn't round it up, so it's 37%. So the question is, does there seem to be an association between the people who have kids and the people who have pets? So we're going to look at how often that happens, what that percentage is. So if we look up here, does there seem to be an association between the people who have kids and the people who have pets? And I'm going to say yes, because the people who have kids and who also have pets is 65%. So it's not horribly high, but I do think there's enough of association that you could say, yes, people who usually have kids, like in my household, are more likely to have a pet than people with no kids. Oops. Sorry. If you kind of look at that, so this is people who do not have kids and have a pet. The people who have kids. So if you look at the percentage here, 65% is 37. I do think that's something to be noted.